right, well, we're going to go ahead and get started. Welcome, everyone, to our Powering Real-Time Loan Underwriting at Vontive with Materialize. We have here our guest customer, Wolf Rendell, Director of Data Products at Vontive, and we have Stefan Hausman, Field Engineer here at Materialize. We should expect about a 40-minute presentation followed by a 15-minute Q&A. So we will be monitoring the chat throughout the webinar. Feel free to throw your questions in there. And with no further ado, I'm going to kick it off to our wonderful speakers. And again, thanks for joining us.
Hey, everybody. Thanks for joining us. My name is Wolf Rendall. I'm the Director of Data Products at Vontive.
And I'm Stefan. I'm a field engineer here at Materialize.
I'd like to start by sort of giving a little bit of an overview of what Vontive is. Obviously, we're here to sort of say how partnering with Materialize helped our business process out, and we will get into that. Just to sort of bring you into our world and where our problems started, Vontive is a platform for originating investor mortgages. If you really try and permute all the different scenarios that we handle out, there's about 28 different products. And that includes, ground up construction, fix and flip, buy in order to rent, cash out mortgages, buy purchase lending, rate term, delayed purchase, all kinds of different scenarios that people could want to find mortgages for an investment purpose. We will do those. And kind of our secret sauce with all of this is that our platform is really good at reusing documents. So on your second or third attempt to underwrite a mortgage with us, we can usually close you within, 72 hours or something like that because we're reusing documents from before. And eventually, we create these loans, we send them off to Wall Street where some interested party purchases them. And, we pride ourselves in having an industry-leading default rate. So, typically an industry standard default rate for these kinds of loans might be in the 5% for your total portfolio. Ours is hanging around 1%. And part of that is because we've got great borrowers. And part of that is because we've got a process in place to do a lot of checking to see that, all of the data points that we think are going to the loan are actually what the loan contains. And so what does my team do? Data Products is responsible for everything having to do with developing credit policy and these underwriting tools that I mentioned so that we can make sure that the borrower and the property have all the features and characteristics that we say they do when we write the loan. We also do plenty of things having to do with business intelligence and how's the business going and what channels are bringing in new volume. And then we also have a mandate over AI and ML development, and hopefully we'll get to talk a little bit about that towards the end. And one of our major areas that we worked on is a data hygiene product here at Vontive. So I mentioned that we've got these, let's call it 28 different products. Many of them have similar requirements and eligibility guidelines, but every single one has a little bit of a different twist and a little flavor to it. And it can kind of depend even on what documentation is being presented. So for example, I've got two hypothetical loan situations here. Both loans are for a loan amount of $500,000. The first loan has an as-is value on the property that's securing it of $600,000. The second one has $550,000. Okay, these are kind of the same. And then one interesting thing that's coming up is, we have an appraisal that we had to order for both of these properties. On the first property, the appraisal lists a replacement cost for the building of $300,000. And the insurance policy that covers the building for hazards and destruction and that kind of thing says it's covered up to $320,000. The second loan, the appraisal did not list a replacement cost, so that's pretty common. There's lots of appraisal providers. Some of them have some fields that come back in the appraisal, and others have left certain parts off. And it has insurance coverage of $400,000. Now, even though this insurance coverage is higher than on property 1, property 2 is still an invalid loan for us because if the replacement cost is not given, then the rule for our underwriting guideline would say that it actually has to cover the entire loan balance so that we can guarantee that us and eventually the downstream holder of the loan who buys it from us is able to be made completely whole in case the unforeseen happens. And so you can imagine how difficult these kinds of guidelines are for a human processor to keep straight and to just sort of like, as the loan is changing and the loan amounts are changing, to have all of these checks validated at every step of the way, it's basically an impossible task. So to get that moving and to make sure that we weren't underwriting and producing loans that fell outside of this policy guideline, we wanted to build a system for automatically validating these data points. And so what we did was we started using DBT, a popular framework for writing lots of operations in databases, to build out a set of SQL queries. And those SQL queries would produce views, and those views would sort of warn us and raise alerts about certain values being out of compliance. And so, we wanted to make sure that we were surfacing errors or values out of compliance as early as possible in the process so that they could be addressed. And then also, we have some really, really bad outcomes that can happen if we allow a loan to sort of get through all of these guidelines and guardrails through the finish line. And if something has to be restated, we can actually have our worst possible outcome, which is having to repurchase the loan. So things were off to a pretty good start. What I'm showing here is the average total edits that one of our data sets, and data sets is just our organizational term for the appraisal is a data set, the lease that's in place is a data set, the purchase and sale agreement is a data set, the borrower's credit is a data set. So all these different data sets, we've got about 40 total that we fill out in order to make these loans. Our very first loan catches, that's what we're calling them, these set of SQL queries, was directed at hazard insurance because it's one of the things that trips us up the most often, and we saw the most benefit from it. So when we first started with these query systems, you can see that according to this red line, which is the average total edits that an insurance data set would receive, and according to this blue line, which is the average edits that it would receive in the first week, after we implemented this loan catch check thing in February of 2024, we saw that the average number of edits on one of these data sets did not change. So the red bar stays pretty much constant. But we did notice that these first week of the data set, the first week of loan underwriting or the loan being in our system, the share of first week edits rose dramatically. And that's because we were changing people's behavior. As the people who were working on these loans were interacting with our system, they were seeing these alerts that these values were out of compliance, and they were addressing them a lot earlier. So this is a really good benefit for us. So you can see that the share of us catching problems in the life cycle of the loan shot up from 50% of the problems caught in the first week on an individual data set to almost 80% of the problems caught in the first week of an individual data set, which really helps when you're trying to hit a specific date, a closing date for a buyer or a borrower. They're buying this property, they have to close on a certain date. And if we've got all of our ducks in a row early, that's good for them. Now, one of my favorite terms is victim of your own success. Obviously, with that chart that you saw in the last slide, this system became very, very popular. Every department had something that they were interested in for having automated checks for. And so, the requirements and the number of checks that were being requested just exploded. And the way we had set this up, it was just, a Lambda function that was running these queries against our data warehouse. And, every query that we added a little bit more calculation time because we were trying to union them all up. And, we have this big sprawling system now. Eventually, we got to about 25 checks and our system just timed out at that point, right? So we're working in an API gateway where results have to be returned within 30 seconds. We were no longer able to do that. And so when we faced this problem, we weren't going to be able to argue for oh, no, we can't do any more than this number of checks. We had to find something more efficient. So we had to figure out a way to delegate the work out better. We looked at a couple different solutions, but we thought that Materialize had the best offering because it allowed us to keep our DBT infrastructure that we'd invested time in, number one. And then number two, when we looked at the cost benefit analysis of managing our own our own Postgres server with the specific plugins, which are not supported in AWS, but which are, these third-party plugins to do incremental view maintenance, we looked at the cost benefit and we really the choice was very clear that Materialize was our way forward. And with that, I'd like to turn things over to Stefan to sort of go through the technical aspects of what a Materialize implementation really does.
Cool. Thanks, Wolf. So the problem Vontive has been facing is actually pretty common in the industry. And that's not a bad thing. It's just a consequence of how we build stuff, right? When you get started with a new project, a relational database is just a very natural place for storing your transactional data. And then over time, you get interested in what's actually happening in your business. So you start to run queries against the data in your database to analyze the data that's there. And over time, this may become more complex and more queries that you're running so that you'll put more and more pressure on your upstream database. And at that point, it's quite common to create maybe a read replica so that you can offload these complex analytical queries from your transactional traffic. And that works for a while, but it doesn't resolve the fundamental tension between like the analytical nature of the queries and the things that a relational database is good at. So one common way to deal with this problem is to offload these analytical queries into a data warehouse. So you set up an ETL process to pull the data from the upstream database into the data warehouse so that you can then run your analytical queries very quickly, because that's what data warehouses have been optimized for. But that doesn't come without trade-offs. When you're running analytical queries when you're querying your read replicas, you're working on fresh data, but your queries are slow. And on the data warehouse, your queries are faster because the data warehouse can evaluate them more cleverly, but you're essentially operating on stale data. And Materialize has been built to resolve this kind of tension. So Materialize is an operational data store that helps you to transform, deliver, and act on fast-changing data by just using SQL. So with Materialize, you can integrate data from different sources, transform and enrich them, and then have them in a form so that it can be easily queried by downstream consumers. And in this way, you can combine fast queries on fresh data without making any compromises on the consistency or the expressiveness of the queries you can run. And to show you like a bit of behind the covers what Materialize does and how it can be much faster than relational databases, this is how the architecture looks from a very high level. So it all starts with continuously pulling in data from the upstream data source. So if you're using a relational database such as Postgres, we can directly connect to the change data capture log of your database and continuously pull in these changes and expose them inside Materialize as something that looks like a table. And in addition to databases, we also support pulling in data from Kafka, or you can even make post requests against a webhook, and the data is then also exposed as a table in Materialize. And once the data is inside Materialize, you can then go ahead and run your queries or create views and models that express your business logic, and you can then query the data. And Materialize isn't fast because of this continuous data load, but because we support incremental view maintenance, which basically means that we are continuously updating the results of the views that you care about. So instead of doing work on read, which basically means the work is done when you submit a query against Materialize, we do work on write when the inputs change and adapt the results of the views. So when now a query is issued against Materialize, we just need to return the pre-computed result. And in this way, we can not only respond to complex query much faster, we can also support a much higher concurrency because querying the results doesn't add additional work on Materialize itself. And we can sustain that while providing strong global consistency within Materialize. So no eventual consistent results. You can really trust the results that you're getting back from Materialize. And because we are doing incremental view maintenance, there are now two different ways how you can access the data. The first one is the more traditional pull approach, where you're using a Postgres client to connect to Materialize and pull out the data. So we are Postgres compatible. So any Postgres client that can connect to a Postgres database can also connect to Materialize. And this can be like SDKs or BI tools such as Tableau or Power BI. And you can just point them to Materialize and query the data to render your reports or whatever it is that you want to do. But in addition to this traditional pull model, we also support a push model. So because we are constantly updating results, we can actually push out changes the moment they happen. So we can send notifications into Kafka the moment the data of the views you're interested in changes. We can also push data to S3 and support something that is called subscribe, which is basically just a long-standing connection. So you can issue a SQL query against Materialize over a long-standing connection. And whenever there's an update to the result, we can send a notification back to the client, which is really useful if you're building these event-driven application and want to respond to changes happening in Materialize. And in this way, you can, for instance, keep your caches always warm, right? So you can export the data into a cache, and whenever there's a change, you can proactively push that change into the cache. And this allows customers to cover a wide range of different use cases. And I've just included the three most common use cases on this slide. So the first one is query offload. And this is essentially what we've been discussing so far as part of the architecture, but also what Wolf has been talking about. So with query offload, you can offload your complex analytical queries to Materialize, whereas your transactional traffic stays on the primary database. The integration hub pattern is then an extension of the first one, meaning that in addition, you're not only looking at a single database, but you can pull in data from multiple upstream data sources, then enrich the data, transform it, denormalize it, so that it is in the form that is useful for your clients for consumption. And the operational data mesh is then one step further, where we are on some kind of microservices domain, and we have different teams that are independently acting on data, and they can use Materialize to publish data products and then run queries across multiple data products from different isolated teams. And this all integrates with dbt. So as Wolf has already mentioned, like dbt is infrastructure as code for databases. So we can use dbt to create views and objects in a database in a very consistent way. And we support dbt through our own dbt adapter. And if you're using dbt today, it works as if you were using a traditional database, with one difference. Instead of scheduling dbt runs to refresh your model, with Materialize, you execute dbt run once and only once, and we will then keep the models up to date for you. So no more scheduled refreshes of dbt run, no complicated incremental models in dbt. You just define your logic as SQL queries or as models, deploy to Materialize, and we keep the results incrementally up to date for you. And that way, you can also adhere to software development best practices. So you can check in your models in version control. You can run tests and lins and use CI/CD. And interestingly, even the tests, the dbt tests, are evaluated in an incremental fashion. So we can send you a notification the moment a test fails, rather than having to wait for a scheduled test run that's happening once at midnight or something. And because we integrate natively with DBT. Like your workflows don't need to change. If you're using Postgres with DBT today, you can just point DBT to Materialize and it should work. And you can continue to benefit from the goodness that comes with DBT, like templating and using macros to really build your expressive nodes. Cool. And with that, I'm going to hand it back to Wolf, who's going to talk about how they used Materialize to solve the problem you mentioned in the introduction.
Thank you, Stefan. Yeah, I love seeing this spelled out so clearly, and it just connects me back to the challenges that we were working through. As Stefan mentioned, it does the work on read, or it does the work on commit, right? So on commit, refresh. We were in a world where we were at 25 queries. Every query was adding basically a second of work. Moving from that system to an incremental view in our own AWS environment was looking like it was going to be a little bit too much of a challenge to maintain, extra AWS costs. So we went with Materialize. We had to do basically no setup work. We set up our cluster, had our existing DBT code, and then just basically pointed it somewhere else. So instead of at our existing data warehouse, we just pushed it towards them. And when we did that, we noticed that our latency went down to less than 1 second, no matter how many tests we added. So we had been basically bottlenecked at 25. Once we had the 1 second latency, we had a bunch of tests that we were looking to deploy. And so we just added them. We've expanded to well over 250 now from that 25 back in February. And there's many, many more. We're probably going to finish Q1 at around 1,000 checks, I would imagine. And when we got this low latency, it actually allowed us to sort of shift our paradigm for how we were thinking about alerting in our system overall. So we used to just show the results of the rules engine just right here on this rules tab within our workbook. I'm showing you here a screenshot of how our portal looks. But then with latency so low, we expanded it to having it on the offers page. So anybody who's reviewing an offer that they may have created for one of their borrowers now sees an alert when something's out of compliance. The individual data sets where somebody might be entering purchase and sale information or title information, we've got an alert there to show you that, your title commitment is less than the title insurance, or is greater than the title insurance. So this is out of compliance for us. We've added these contextually aware alerts to lots of parts of the platform because it's coming back to us so quickly. And so now that I showed you the first chart where we had this behavioral change for just the insurance data set. And as I mentioned, we've got about 40 different data sets. Now we've got coverage for almost all of these 40. And I was very curious when we started this project to create this chart in particular, because this is not a chart about any individual data set. This chart is telling you how much time does it take for a loan to enter into our system as a submitted loan and then exit as a funded loan, like a loan application to a funded loan. And as our Materialize switch happened, you can see that we, basically took things down from consistently like 20 days to underwrite world to a 15 days to underwrite world. So improving our pull through by about 25% by increasing our performance here by like 99% on this one product. So, we're just going to wrap up with a couple, takeaways from that change. So, we were able to reduce our time spent validating documents. And the benefit for our clients was that we were closing on time. The loan was as stated. So that's the borrower perspective. So they're having a great experience. The loan buyer is having a great experience because the loan they're buying actually says the things that it contains. And we've checked this automatically and with humans. One of the worst outcomes I mentioned that we can have is when we've sold a loan off and we have to repurchase it from the person that we sold it to because there's a material difference in the facts of the loan, either the borrower details or the property details or something like that. So if we have that, they can ask us to repurchase it and we have to. In 2023, this happened 51 times where we had sold a loan and then we had to buy it back. In 2024, this has not happened at all, ever. And so we've basically used this system to chop off the tail. If you look at your distribution of outcomes and that the tail end of that is your bad outcomes, We basically use this to chop off our bad outcomes. Because we've got this new system where we're putting this contextually aware in more places, displaying our alerts, we realized that we could actually ramp this up even harder. Now we've kind of hit the point where the way that our data sets are architectured, we kind of ran out of questions that we can answer with the field data that the forms for these data sets are capturing. So, the appraisal data set might contain 15 or 20 values in it, and the purchase and sale agreement might contain 15 or 20 values in it. And prior to this, we were asking humans to read the docs and fill it out. Around this same time, we started using an LLM to read the documents. We have prompts that sort of ask the LLM, oh, can you tell me what the appraised value or what the replacement value of this property is based on this appraisal document? And it does its best and gives us some values out. We're realizing now that we can actually ramp up our data set development to, instead of 15 to 20 fields, maybe 40 to 50 fields that we're pulling out of these sets, because we're not asking a human to read it anymore. We're not asking a human to keep all the rules straight for what these different values means. We're training the LLM to do it. And our LLM that we're using is Claude Sonnet 3.5, because that one happens to do better at like image parsing tasks. But now, instead of sort of, training operators and having these big cross-functional discussions around, oh, how can I do this? Is it worth it? We just tell the LLM, you have to extract this now. And then we go to our data set schema in the production database and just add a field name there. And we've got this pipeline where we're parsing it. So, partnering with Materialize to get this sort of efficiency in this loan catch project has kind of changed our engineering culture in a big way too. And that's maybe a change that we didn't foresee. So in addition to not having to purchase any loans back that we already sold in 2024, we're really excited with this marriage of AI that Materialize kind of opened up for us. Oh, and here's sort of just a screenshot of sort of what our AI implementation looks like. So you can see, in Bedrock, we're asking it to parse these things for us. And this is really a paradigm that we're excited to accelerate in 2025. All right. And thank you so much for listening to the Vontive spiel, like what we learned from this process of integrating with Materialize. It's been a great business decision for us. So handing it back to you, Stefan, for your conclusion.
Yeah, so thanks a lot. I hope we got you excited about what's possible with Materialize and sparked some ideas how we can use it to solve your business problems. And with that, we are going to open it up for questions. Well, thanks a lot.
Yeah. So thanks, Stefan and Wolf. We do have a few questions. Janelle sent a question saying, can I use Materialize to join data across databases?
Yes. So one of the patterns we have discussed is this integration hub pattern. So we talked a lot about how you can bring in data from one database, but nothing prevents you to create sources that pull in data from multiple upstream systems and then all combine them in Materialize. And that can be useful if the data you need to make a business decision is coming from different systems that may be used by different teams. And with Materialize, you can just pull in the data, combine it in the way that helps you answer the question, and then act on it while things are changing.
Awesome. And then our next question from John was, what clients are supported to read data from Materialize?
We are Postgres via compatible. So that means basically anything that can connect to Postgres today, you can point it at Materialize and it will start working from there. So this could be either an SDK that you're using today or BI tools such as Power BI or Tableau, Hex, all the common BI tools that natively support Postgres. You can point them at Materialize and then start visualizing the data as part of your reports and have the data that you're using really fresh so that the reports always reflect what's happening right now rather than having to wait until the data refreshes at midnight as you would with a data warehouse.
I'll say too, just on our side, we just use the standard JDBC connector with an account. on our Materialize, like in our Materialize system. And the Materialize console is actually really, really good for, it has a lot of monitoring. It has a lot of like query history, and it just makes it very easy for us to do it that way. Like just your standard universal connector.
Yeah.
Awesome. Thank you. And then our final question is, does Materialize replace a data warehouse?
Right. So the use cases we have discussed so far and that make the most sense with Materialize are these operational use cases where you want to react to changes or make a decision of something that happened in like the last few moments or the last days or something. So that's where Materialize really shines, and where we can help you to build a solution where you can react to these changes dynamically. But that doesn't mean that we are going to replace a data warehouse. So if you're looking at use cases that are traditionally powered by data warehouses, is like running reports of like what was the revenue like in the last year or the last 5 years or so. So like these large analytical queries, that's something you would commonly still use a data warehouse for. So I would think of it as like that. It's basically Materialize is this operational data store that sits between your transactional databases and your data warehouse. So you can use Materialize to bring together the data from different sources, enrich it, and then have it ready for consumers. And a data warehouse can be one of these consumers, where you can then run analytical queries over like a long period of time to make sense of what happened over a certain period of time. But when you're looking to react to things that happened in the last few moments, that's where Materialize makes a lot of sense.
Awesome. Well, thank you all, Stefan and Wolf, for your time and your presentation. Thanks to all of our attendees. We will have the recording on demand for those who attended and could not attend shortly. So we'll be sure to share that out with everyone. And again, thank you so much for everyone's time today. Wishing you all a wonderful rest of your day.
Thank you.
Thanks a lot.
Thanks
Cheers. Bye.
all.
Here. Have a good one.
Bye.
Bye-bye.
Cheers.
Bye.